This is Saudi Arabia. 95% of the country is a scorching hot desert, dunes, and infertile land. Even though Saudi Arabia is one of those 6 countries that doesn't have any permanent rivers and has only 4 inches of rain a year, it exports wheat, vegetables, fruits, dairy products all around the world. Even in the 1990s, Saudi Arabia was one of the largest wheat exporters in the world. If we zoom in, there is something interesting going on in this country. There are a lot of huge circular granaries spread out along the desert all across the country, and even in the middle of the desert. And these are farmlands, more specifically, center pivot irrigation farms. The sheer magnitude of agricultural projects in Saudi Arabia has been huge. For the perspective, in 1961, it had 11,400 square kilometers of arable land, comprising 0.5% of the country. And in 2016, it has almost 35,000 square kilometers, which is triple the amount of fertile land as compared to 60 years ago. 35,000 square kilometers is bigger area than the countries like Belgium and Armenia. In the past 60 years, Saudi Arabia have transformed 24,000 square kilometers of desert infertile land into fertile soil. For the perspective, 24,000 square kilometers is a bigger area than the countries like Slovenia and 2 times bigger than Qatar. And the question is how this desert country transformed big areas into fertile land, and how with its 1.5% arable land can produce and let alone export agricultural products. When most of us think of the Middle East and Saudi Arabia, we think of scorching sun, endless oceans of sand dunes, and one of the most inhospitable climates on Earth. But that wasn't the case in the not-so-distant past. About 10,000 years ago and before, it was a place of rolling grasslands, forests and jungles watered by torrential monsoon rains, just like in the tropical Southeast Asia. Water is the most central element in the greening of the area, and you might be thinking how they got so much water to sustain large-scale farming. Well, engineers tapped into ancient river channels now buried by the sand seas. The fossil waters were trapped in aquifers as deep as 1 kilometer below the ground, and it was accumulated during the periods of wetter climates in the Pleistocene glacier epochs between 10,000 and 2 million years ago. Saudi Arabia sits on huge reserves of not only oil but water as well, and it has been pumping water from the glacier lake aquifer to enable farming and milk production on a large scale. Generally, irrigation of crops is important to maintain the abundance of food for a growing population. Crop irrigation and farming requires large amounts of water and energy. These are expensive and becoming less available. Therefore, it's important for farmers to conserve water and energy when irrigating crops. Conserving water and energy requires good irrigation management methods. So one of the best ways to manage water and energy is the center pivot irrigation method. Center pivot method was created by a farmer named Frank Zybach in Colorado, and it is recognized as one of the most effective methods to improve water distribution to farm fields. As the name suggests, center pivot irrigate in a circular pattern around a central pivot point. Pivots are capable of applying water, fertilizer, chemicals, and herbicides. This versatility improves the efficiency of irrigation practices by using a single piece of machinery to perform several functions. Center pivot machines have been used in irrigation for decades in different countries, and it increases yields and less water waste as compared to other irrigation methods like flood irrigation. And Saudi Arabia has been building center pivot irrigation for 50 years now. However, they have nearly emptied what was an aquifer the size of a Lake Erie. Since Arabian Peninsula receives very low rainfall, aquifers are not being replenished. The prevailing winds are from the west and contain almost no moisture after traversing northern Africa. Moreover, the western side of Saudi Arabia is where the mountains are, so to speak, the Arabian Shield, and most rains fall on the western slopes and flows back to the sea unused. So Saudi Arabia is suffering from a major depletion of water in its aquifers and the risk of disintegration of its agriculture as a consequence. To prevent this catastrophe, Saudi Arabia has bought agricultural land in the United States Argentina, Indonesia, and a number of African countries. And Saudi Arabia is ranked as a major buyer of agricultural land in foreign countries. But there are some natural solutions to make desert into agricultural land. As we highlighted how most of the rain falls into the western slopes of the Arabian Peninsula, there was an interesting experiment in the Al-Bayda area in the western Saudi Arabia. And as we have talked in a video how African countries are building the Great Green Wall to stop desertification, and one of the main causes of fertile land becoming dead and eventually desert is overgrazing by animals. So historically, there were pastoral nomadic Bedouin tribes roamed in the Al-Bayda area. Because of urbanization and modernization, Bedouin tribes were obliged by law to settle in one area. Unavoidably, the area was overgrazed and the once fertile land was nothing but rocky desert. Two royal Saudi princesses visited the area, saw the crisis, and initiated a development project led by Stanford University permaculturist Neil Spackman and Harvard University bioethicist Mona Hamdi. For 8 years, Spackman lived with Bedouin communities building rock terraces and check dams and carving wide shallow ditches in the land to trap rainwater and create a stream. They also built a bat house, a pigeon house, and planted drought-resistant trees to mimic nature. The project ran for about 7 years, and in 2016, funding was cut, and then a 2-year drought ravaged the region. Most of the trees died out and the whole project was in jeopardy. But in 2018 and 2019, rain fell again and flowed through the terraces and dams that two scientists helped to build. After rainfall, the whole area turned into rich savanna as compared to the desolate desert before the start of the project. Mountainside terraces trapped rainwater and gave life to the soil. Now it's lush and green, teeming with life. Al-Bayda area is a geographic fractal, meaning it follows the same pattern as all the region's watersheds. The entire west coast of the Arabian Peninsula characterized watersheds. To 90% of all fresh water flows to the Red Sea in flooding events without trapping or using the water. For example, in the Al-Lith area, a typical single flood event that flows to the sea is enough to irrigate 130 million trees for 3 years. Al-Bayda project is a profound example on how to make a desert into a savanna, thriving with life and greeneries by harvesting and managing floodwater. If this project can be magnified to the entire west coast of Saudi Arabia, this whole region, which is more than 30 million acres or 121,000 square kilometers, could be transformed into agricultural land. It's quite significant. This area is bigger than the Netherlands, Belgium, Switzerland, and Denmark combined. It will cost billions of dollars and time, but the agricultural capacity of Saudi Arabia could be multiplied by at least 6 times, increasing the GDP by 30 to 5% and increase of rainfall in the region. As we have talked about reversing desertification in Africa by building giant green wall video, the vast majority of carbon gases is in the fertile soil. If the soil dries and becomes a desert, carbon gases will be released to the atmosphere. So in this case, if the soil comes back to life, it traps huge amounts of carbon gases back into the ground. So it is a win-win situation. Saudi Arabia uses desalination plants for fresh water for its population. And as we have talked in desalinating seawater video, desalinating seawater into fresh is energy intensive and it uses natural gas and coal in the process. But modern desalination plants are mostly thermal, which is coal and natural gas that emit carbon gases. And the second method, membrane-based reverse osmosis, which runs with electricity. Coal and natural gas are not an option because of global warming, but reverse osmosis is doable because electricity can be harnessed from nuclear energy. And we have talked in our video how nuclear power is the cheapest and safest form of energy. Well, if you want to learn about it more, please check it out. So, in order to make the land green, we need water. To get water, we need desalination plants. For an efficient plant that doesn't emit carbon gases, we need green energy. So one of the best options powering desalination plants is with nuclear energy. So it is all